Limits. Indeterminate forms. In finding the values of limits, sometimes we obtain forms such as 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 0 power 0, 1 power infinity, infinity power 0. In such cases, use some techniques to obtain the limits. Now, limit extends to a minus f of x equal to L, which is left-handed limit. Limit extends to a plus f of x equal to L, which is right-hand limit. Therefore, limit extends to a f of x equal to L exists. Limit exists such that epsilon greater than 0, delta greater than 0, such that mod of f of x minus L is less than epsilon whenever x minus a is less than delta and greater than 0. Limit only exists if the left hand limit is equal to right hand limit, and limit cares about only what happens on left side and right side but doesn't care the point of a. Now we move upon to standard limits. Limit extends to a x power n minus a power n by x minus a equal to n into a power n minus 1. Limit extends to 0 sin x by x equal to 1. Limit extends to 0 tan x by x equal to 1. Limit extends to 0 1 plus x power 1 by x equal to e. Limit extends to infinity 1 plus 1 by x power x equal to e. Limit extends to 0 a power x minus 1 by x equal to log a to base e. Limit extends to 0 e power x minus 1 by x equal to log e to base e, that equal to 1. Limit extends to 0 log 1 plus x by x equal to 1. Now, limit extends to a some constant function c into f of x equal to c into limit extends to a f of x. Limit extends to a constant function c equal to c. Limit extends to a x equal to a. Limit extends to a x power n equal to a power n. Limit extends to a root over nth root over f of x equal to nth root over limit extends to a f of x. Limit extends to a f of x to the power of n, that equal to limit extends to a f of x whole power n. Now we move on to algebra of limits. Limit extends to a f of x plus or minus f of x, g of x equal to limit extends to a f of x plus or minus limit extends to a g of x. Plus means plus, minus means minus. Limit extends to a f of x into g of x, that equal to limit extends to a f of x into limit extends to a g of x. Limit extends to a f of x by g of x, that equal to limit extends to a f of x by limit extends to a g of x, where denominator is not equal to 0. We move on to infinite limits. Infinite limit. Limit extends to 0 plus 1 by x equal to infinity. Limit extends to 0 minus 1 by x is equal to minus infinity. Limit extends to a plus 1 by x minus a equal to infinity. limit extends to a minus 1 by x minus a equal to minus infinity. Minus infinity. Let's move upon to limits at infinity. Limits at infinity. Limit extends to infinity 1 by x equal to 0. Limit extends to minus infinity 1 by x, that is also equal to 0. Limit extends to infinity e power x equal to infinity. Limit extends to minus infinity e power x, that equal to 0. Limit extends to infinity e power minus x, that equal to 0. Limit extends to minus infinity e power minus x equal to infinity. Limit extends to 0 e power x equal to 1. Limit extends to infinity c by x power r, that equal to 0, that equal to limit extends to minus infinity c by x power r. Limit extends to 0 plus natural logarithm, that equal to minus infinity. Limit extends to infinity natural logarithm equal to infinity. Now we move upon to sandwich theorem or squeeze theorem. Suppose we have two functions g of x and f of x and h of x. For all x belongs to the interval a b except possibly at x equal to c, c is between a and b such that f of x such that h of x is between f of x and g of x. Also, limit extends to c f of x equal to limit extends to c g of x, both are equal to capital L. Therefore, by sandwich theorem, limit extends to c h of x equal to is also equal to L. Now we move upon to continuity. F of x is continuous at x equal to a if limit extends to a f of x equal to f of a. Here we have left continuous and right continuous. Limit extends to a minus f of x equal to f of a, that is left continuous. Limit extends to a plus f of x equal to f of a, that is right continuous. Right continuous. Now we move on to intermediate value theorem. If f of x is continuous on a b such that c is between a and b and f of c is between f of a and f of b, therefore f of c exists